I don't care.
No one talks enough. Okay, no one talks. Look up. Okay, you have the Thanksgiving break and then come back on Tuesday, test this Thursday. Look at me, look. Okay, a really common thing for people to say at this point in the year is they will come and say, I can't even see how to get started. Okay, so you've got to memorize a few methods for helping you to get started. One method is you read the problem and key phrases or key words will trigger a memory of a flashcard. Okay, and then you use that memory to help you get at least one thing done in the problem. It's very common that if you can get one thing done, the next step will then become apparent. But if you're not spending time with your flashcards now, it won't help to do it the night before because the memories aren't permanent enough. Okay. So anyway, number 4, somebody asked about this. So it says an equation of the line tangent to the graph of this. Okay, as soon as I read that phrase, an equation of a line tangent to this graph, I always draw exactly the same picture, and I always label the picture exactly the same way. Matthew is indicating what I'm going to do, so I go like this. Sound effects for extra attention.
We appreciate it.
This is the graph of y, so make a note of that. Okay, another key to this class, like being able to solve all these brand new unknown problems that you keep encountering on tests and such, is getting the basics down really, really like solid. For example, as soon as I write this, I'm thinking already what this is. So hands up, what am I thinking? Come on. Like as soon as I write this, you should right away be thinking, what is this? Hands, come on, show me. What is this? Adam?
XY pairs.
It's a formula for finding XY pairs here.
All the XY pairs.
It's the formula that we would use to find every XY pair. Now, look. And a lot of people say that, but when it comes time in a problem, they'll completely just abandon that thought and forget how to use it. Okay? It's really simple. If you know the x coordinate you're interested in, just plug in the x, the formula computes the y. The other way around is a little trickier. If you happen to know a y coordinate, you plug in for the y. Then you would have to use algebra or a calculator to find the x that goes with it. Because they're always coordinate pairs. They always go together. 2 points for Adam. Questions? Okay, this idea that you'll see this, you think, oh, that's how I find all the xy pairs. That comes up in problem after problem. It shows up all over the place on the test. The line is tangent at a point 1, 5. So I draw that. Draw the line tangent. It's a dang good line. Okay. We good? Okay. It's not really a line. It's really a whole bunch of coordinate pairs. So there's some equation, just like this equation can find all of the purple coordinate pairs, this equation that I'm about to write can find all of the green coordinate pairs. So for this AP problem, as well as many in the future, if you read these words, equation of a line tangent or line tangent, draw this. Please, Matt.
So for the answer that we're going to get, which is the equation for all of the points in the line tangent to the curve, is specifically for that curve, right?
Mm-hmm.
Okay.
2 points. Yep. Okay, you have to memorize what each of these symbols mean. So let's start here. I'll pay the whole room this time. What does the x and the y in this formula mean? What do they represent? You won't be able to succeed in this class if you can't keep track of the meaning of the symbols. You just can't just do the work. You got to know what the symbols mean. Read.
They represent a point on the line.
So this x and this y is simply some point on the purple. Any of them. It's like just one at a time. But it's just like any point on the purple. And we use the x and the y to find any of the points. Plug in an x, find a y. How many knew it? 0.2 for 3. So in this equation, the x and the y have the exact same meaning. There's an x and y in this equation, so you can find all of these x-y pairs. This m and this x1, y1 have a slightly different meaning. Hands up. What's the m and what's the x1, y1? I wanted to call on Hannah because she's like close. Oh, good. No worries. Connor.
M is the slope of the tangent.
So m is the slope of this line. What's the x1, y1?
Is the x coordinate of where the line is the slope.
Okay, 2 points for Connor. Everybody listen close. Slight, you want to adjust that just a little bit. Okay, m is definitely the slope of this line. x1, y1 is actually any of the points. It doesn't matter which one you pick. We picked this one because it's convenient. It's right there. But it could be any of them. Please. Brian.
Oh wait, yeah, that's correct. Because it could be any of the points on the green line. Not
On the green line. Perfect. This particular point is on both, so it works either way. Questions? So another place people struggle in calculus is they get so lost in all the work, they lose track of the question. So raise your hand if you know what the question is. Like, what are we supposed to be doing here? Like, you get so lost in the work, you just forget what the question is. What's going on?
You're finding the equation of the green line.
Perfect. We want to find the equation of the green line. How many know it? 0.2 per minute.
You're finding the equation at 1,5, or at 1,5.
Sorry, struggling with help. You don't want to say it that way. That's not quite right. We are looking, so this curve that's in purple, so talk with me, Gil. How many tangent lines could I draw to that purple curve? Infinite number. I'm specifically interested in the line that is tangent at that point, yes. But it's still just this line, so 2 points. So really I can do this. All I have to do is find the slope. How do I find the slope of that green line? How do I find the slope of the green line? Let's go Sadie.
You find the derivative.
So I'm going to take the derivative of this. So how many knew that we needed this derivative? 0.2 for Sadie. So come over here. It's y prime. Okay, another reminder, look. Make sure, listen, make sure in your work you are always writing equations as much as possible. That also causes people to get stuck. They're not using equations because many problems are all about the proper use of the equal sign. So y prime is going to be bottom multiplied by the derivative of the top plus the top multiplied by the derivative of the bottom divided by the bottom squared. Question? Okay, something else you need to memorize. I don't have a flashcard, but if you need one, please make it. When you see a big long expression that involves x and constants, or x squared and constants, you should multiply it all out, combine like terms. That always helps. So, here's a dangerous spot. I have to distribute the negative, but I also have to distribute the 3. So 3 times 2x would be 6x. Then the negative would distribute, making it negative 6x. 3 times 3 is 9. Negative distributed would make it negative 9. So my y prime is negative 13 divided by 3x minus 2 squared. Again, you can't get lost in the work. You have to keep track of what you're really doing. So when you see this, what are you supposed to think? So when you see this, what should you be thinking? Yep.
Is the equation to find the x and y pairs on y prime, or on the tangent slope?
Oh, the first one was really good. The other one, actually, everybody pause for a minute. Hold on. I've been doing this a lot today. I'm giving out tickets to people who make a really, 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 really important mistake. Okay? So, the mistake that Gil made was, he started out just fine. Actually, maybe you didn't make an error. I'm not sure, but you keep the ticket.
I will certainly do that.
This definitely would be able to find xy pairs on the graph of y prime. That's kind of a secondary use, honestly. There's a use that we'll use a lot more for. What should you be thinking when you see this hand? Shem?
It's finds all the slopes on the purple curve.
Perfect. This is so I can find any slope on the purple. How many slopes are there, Shem? Good. So that's why there's an x in this formula, so you can identify which slope you want. How many knew it? 0.2 for Shem. Okay,
So for this one, like, I know you said, like, it's always best to, like, multiply them out and then find, like, terms. But for this one, since you already know the points that you're plugging in, don't you think it would be easier just to plug them in first, because then you don't have to deal with, like, that negative sign or, like, just making an error there?
I got you. I vote on some problems it's for sure easier. This one I think it's kind of mixed, but it's a good comment. And you're correct that we're just going to use this to plug in 1. So no, you can stop here. That's okay. 2 points. Anybody else? Cool. So again, you can't get lost in the work. So what should I do now? What do I do now? So Matthew?
Could you not make the formula for the line tangent to the purple curve at 1,5?
So how would you make the formula?
You would have to first plug in the x coordinate for that specific point into the tangent slope equation that you just found.
Well said. So I have to come over here and say y prime at an x coordinate of 1 is going to equal points for Matthew. So now what? Again, just get in the habit of raising your hand. It really helps me see how well people are doing. Like, I know some of you don't like to get called on, but I give bigger rewards for mistakes than for right answers. So, Hadley.
Then you take that, and that's your slope, and you plug it into the equation for m.
Come over here. 2 points for Hadley. Question? Again, please don't memorize what I do. Like, memorize like what the meaning is of each part of what I do. Because they like to shuffle the things you do on other problems. Questions here? That doesn't match any of the answers. So what I always do is I first look up and say, okay, there's no parentheses anywhere. So they have obviously distributed. So I'll distribute. And now I can see the answer. They simply moved the 13x to the other side. It's that one. You want to talk about it?